All right, we are now getting to the lightning talks. All right, so let me introduce the lightning talks. Today, of course, is all about innovation, but it's also about connecting, and it's about learning about some of the exciting things that are happening at startups and other pockets of innovations and innovative companies. We will have ample time this year, today, like we had last year, for you to make those connections and have one-on-one conversations. But to kick that off, we wanted to first give you, everybody in the audience, an opportunity to get a bit of a sampling and see what's in store. And we'll do that via a series of lightning talks. So I'll ask each of the 16 organizations that have been selected for this round to pitch their work in just 2.5 minutes. I'll do the timing and I'll be very strict. So brace yourselves, this is going to be a little bit of a rapid fire. I would recommend to not even attempt and try to internalize everything what you're hearing, but really use it as a way to determine what sounds interesting to you and which of these organizations you'd like to speak with in a bit more detail later today. They will all have a table and there will be ample time after this session for you to interact with them and strike up conversations, maybe see a product demo and so on and so forth. So with that, can I invite the first selected startup, which is Hum.
Well, hello. I'm Dustin Smith from Hum. Publishers sit on a gold mine of behavioral data. This is more than 99% of what they have access to in terms of data asset, and most of this washes away. So what Hum does is we plug into digital systems, we capture and structure that data about people, content, and topics. And so this is really a nervous system for publishers. On top of that, we put a brain, which is Alchemist, which structures all of the insights, recommendations, and predictions. It's a little difficult to imagine in high dimensions, but in this brain live all the content, topics, and people that live within the audience. And as people consume content, we're able to see how they actually travel around in this AI native space. And we go beyond that. We have a supplemental neural net. Hong, we can talk about that later. And this drives predictive interest. So where are people going to go in this AI native idea space? And so you're anticipating where they're going to be based upon their past consumption. All of this is powered by Lodestone, which is our foundation model. You can find the V1 on Hugging Face. We just finished the V2 training run. And so this is the foundation model which keeps all of those people, content, and topics inside its brain. That's all very abstract. So why don't we get a little bit more specific here? Because all the people, content, and topics live inside the brain of Alchemist, we're able to see things like where is there intense interest in a topic and low content for individual publishers. We're able to feed that into a generative algorithm and suggest potential special issue topics. So the top one we're going to select as a potential special issue topic, and we're going to proceed to find the right target audience. So we're going to drop that special issue description and find the predicted audience to be interested in that particular special issue. And we're going to dial in the intensity to make sure that they're very interested, so interested to be a potential author. We're going to build a message to put in front of those potential authors to solicit them to actually submit their information. And we're going to put that message in front of the right person at the right time. Thank you very much.
So $500 million damage was caused by one case of research fraud in the field of Alzheimer's studies. In this particular example, one scientist fabricated 20 research papers by using manipulated and duplicated images. And follow-up research and clinical studies caused a damage of $500 million. Unfortunately, it's not a unique case. 10 million research papers are checked each year, and every fifth one shows image-related issues, starting from small ones up to massive integrity issues like the example in the beginning. The status quo is that images are checked mainly manually. It's a very time-consuming procedure, and many problems are missed. On top of it, we don't have enough experts to perform the checks, so all this together results in substantial financial damage caused by retractions and even worse follow-up research of these 40 papers. As you can see here, it's a very challenging task to identify these issues. So here in the green boxes, we have 2 duplicated images used in unrelated publications from different years, different authors, different journals. And it's not a simple duplication, it's also manipulation because it was rotated, the color was changed, and the scale is different. And it's very, very difficult to identify it manually. But ImageTwin can help you doing that. With our AI-based solution, we are able to detect image plagiarism and manipulations, and we can check for issues within a paper, but also across publications, and check it against a database of over 50 million images. We are covering the most relevant image types, from microscopic images, scale bands, light photography, FACS plots, and many more. And the best part is that our API is now available, so you can easily integrate it into your existing workflow and check for image-related problems within 10 seconds without doing a single click. So please visit us, and together we can increase the quality and trust in science.
Hi, very excited to be here. I literally feel like I'm standing on top of the world here. Thanks to STM for giving me the opportunity to talk about the Creadox Accessibility Bot. What we try to do here is to look at the practical issues of making content more accessible and try to see if we can create a bot based on harnessing the power of AI to make sure that content is much more accessible. Who are we? We are Creadox. We are an ecosystem for scholarly publishers, technology-led solutions to streamline publishing workflows all the way from submission to distribution. Why should we be bothered about accessibility? I don't really think I need to talk about that because I'm preaching to the choir here. But we all know that there are some practical issues, overheads, and issues with respect to making sure that the content that we are publishing is actually accessible enough. So here comes the Creadox Accessibility Bot. What we took a look at is to see if we can make the images adhere to the alt-text long descriptions for figures, enhancing low-quality images, and optimize table formats for better readability. So a quick look at what the bot really does. I'm not going to get into the details, but let's take a look at some of the examples. So we fed in this image of a car traveling down a tree-lined avenue, and that's the alt-text and the long description that the bot was able to generate. I think that's fairly, reasonably accurate. How does it do when we feed in Venn diagrams? Again, I think, a fairly good start, I would say. Sure, there's a lot of other enhancements that could be done, but the bot was capable of generating a decent alt text and long description. What happens if the image is not of good quality? Can the bot enhance the images? And we were able to, successfully increase the clarity of the images. The bot is also self-aware, so the icon of the bot was very poor quality, and it was able to make it a much higher resolution. On our roadmap is also to do more around the tables to make sure that the content that is being published is adhering to the accessibility guidelines. So again, the accessibility bot ensures compliance with accessibility guidelines for images, provides a better content consumption experience for the reader, and enable accurate identification of tables by screen readers and ensuring compliance with accessibility guidelines. For more details, please catch me. We have a table at the back. Thank you so much.
Okay, show of hands. Which publishers or societies yet do not care about turnaround time of the publication process? Okay, that's what I thought. So thank you, I'm Nishchay, and today I'm going to talk about time. It's a very valuable resource because I've only got 2 minutes to talk about pre-flight. Across publishers and societies, editorial desk is also aware of time. They are under immense pressure to make sure that they ensure accuracy, originality, and ethical soundness of the research that is maintained, and that too at a very short turnaround time. And then there are costs. There is cost to manage the manuscript. There is cost especially when the manuscript is retracted. Pre-flight is an AI-powered solution that empowers editorial teams to streamline their process, to streamline their workflows without compromising on ethical integrity. It conducts checks across 3 main categories: research integrity, language, and technical compliance, and makes sure provides the editorial team the AI tools that they need. Behind pre-flight, there is a dedicated team of software engineers, machine learning engineers, and most importantly, a research team that constantly looks at the market, looks at the evolving industry of retractions, evaluating industry of technical checks, and evolves the tool. Once the manuscript is submitted, it goes through multiple layers of checks across 3 categories over multiple dozens. And there is also an optional human check available where reviewers from Cactus can come in and help look at the integrity of the manuscript. This hybrid approach provides the editorial desk with not only faster processing, but also gives them the resource that they want, which is time. Okay, this is the sample dashboard. So in this era of instant gratification, if you folks are looking for a product that helps your editorial desk save time, we are at the back of the room. We have a table called Pre-Flight, and we've got a box of chocolates. Thank you.
Hello, good morning. My name is Josh. I'm from Cite. We are building the next generation of citations with many of you in the room. When you look at a research article today, you naturally look at where is it published, who are the authors, what are their affiliations, and then some metrics. If you click through to traditional citation indices, you will see a list of citing articles. With Cite, we go deeper and show you the contextual information of citations. We have built Cite using a lot of machine learning, or AI generally, to analyze millions of scientific articles. We've done this with cooperation and licensing through publishers. And so this is now out of date. We're over 1 billion citation statements extracted and analyzed from research articles. This information is now live on millions of articles, helping better contextualize and understand research. And so you can see this across many different publishers now, but it's not live on ChatGPT. So ChatGPT has taken the world by storm, exceedingly easy to use, very powerful, but it comes with problems. It makes things up, it can hallucinate, it can give real references. Or fake references. And so what does ChatGPT need? Well, it needs citations. We found ourselves in this unique position where we have access largely to the world's knowledge to kind of provide citations to large language models. And we've done that with something called Assistant. Assistant is effectively like a ChatGPT for research, except it is providing real references and not just references, saying this is an article, but one that has presented supporting or contrasting evidence. And so you can ask questions in plain language, you get real references that you can see how those references have been cited, and you can kind of mix the best of these both worlds. So with the flexibility and the power of ChatGPT, and then the trust and data and evidence and analyses of scholarly articles. And so this, I think, is just one foray, but I think publishers in the room actually have a very unique opportunity with AI that I would love to talk with you about afterwards. We do have a table. We don't have any swag, though, so you'll have to just look for me. Thanks so much, and I'll pass it over.
Hi, everyone. I'm Narendra Kumar, CTO at MPS Limited. I'll be talking about DigiCore Pro. It's a digital publishing platform. End-to-end, it supports from content submission right up to hosting and delivery. Basically, DigiCore Pro has been developed on the basis of our heritage platform called DigiCore, which is a digital publishing suite. It supports single source publishing with modular architecture, API-based integration with third-party platforms. It supports open access models as well. The overall end-to-end workflow, it condenses the entire workflow, right from pre-acceptance to post-acceptance activities all the way. It leverages AI ML right across the end-to-end workflow. So right from content authoring, online submission, editorial, peer review, tracking, production, and finally right up to content hosting and delivery. These are some of the unique features of DigiCore Pro, include single sign-on, wherein it supports ORCID, Web of Science, Google, and so on for integration. The content itself gets structured automatically at the back end. It identifies all the metadata and the content and loads it into the platform, wherein all the metadata gets loaded up, like affiliations, authors, tagging, all of this. And it's also integrated with third-party databases for validation of some of the metadata. The abstract itself and the keywords get loaded automatically into the platform and made available to the reviewers or the authors. It also supports plain language summaries and graphical abstracts generation using, again, AI/ML at the back end. Keyword generation is also automated within the platform, and it also has a taxonomy of keywords for the author to choose from for that particular journal, for example. ML-based content structuring happens all for the entire content itself. The unique feature of DigiCore Pro is that it's got a digital editor built into it so that the content can be reviewed by authors, reviewers, and editors. within the platform itself. It also supports reviewer search and assignment with integration with PubMed, Google Scholar, and other databases. Editors and reviewers can come in and provide feedback and comments on the content itself, right on the platform itself, and they can also make, complete can give you the recommendations based on pre-configured forms within the platform. As for the post-production activities, again, it leverages AI/ML here again for some of the activities like image processing, right from cropping, resizing, improving the clarity, enhancing the quality, and so on. Also supports language editing through the LLMs, again, for the platform, and also has DI checks and compliance, alt text generation, and also it's got an AI-powered chatbot to help the users. Thank you all.
All right, hey everyone. So I'm here to present Signals, which launches today. So publication fraud is really threatening integrity of published research and publisher reputation. I don't really need to tell you more about paper mills. Other people have done that already. But yeah, we're seeing more and more retractions due to these fraudulent articles. So Signals was to help prevent publication fraud. So we're doing this by enabling users of Signals to gauge the legitimacy of a research article. We do this in a new way, where we do this by surfacing robust insights about the authors of the article from the article's metadata. So this approach is in contrast to most checks that publishers currently do. These are normally checks of the content, the text, the images. But the challenge here is that these checks are in a constant arms race with paper mills. So they're now using generative AI to make content that looks more and more real. It's really hard to distinguish. But we're using metadata, and this metadata actually improves over time as more of the authors publish more, and that work that gets engaged with and cited. So we're looking at information inside self-citations and their citations, information about the institutions where authors are from, retractions and comments that articles pick up over time, and the quality of the journals where authors publish. So there's various ways to interact with Signals. If we want to take a look at an article that's already published, we just enter a DOI, and we can really quickly get insight out of the article, which gives these signals, which in this case were in green, and we aggregate those to give an overall risk score on the article. It doesn't have to be published, so an editor can take a PDF of a submission, they can add it into Signals, we'll parse that, and again, be able to get the signals and the risk score of the article. We don't just need to look at single articles, we can also look at an entire journal's portfolio, so we can take, say, a whole year of publications of a journal, aggregate all those signals, and give a risk score for that journal too. So, in summary, we're providing insight into an article's legitimacy based on metadata. We've got the MVP launched today, which works really well for articles with DOI. We can also do it with articles as PDFs. We can do journal analysis on a large scale. We are currently being tested by several publishers. We are also looking for a publisher or platform to continue building with. If you want to try it yourself, you can go on that QR code. All right, yeah, sort of thing. So I've got a table over there. Come and give it a go. Yeah, let me know what you think. Thanks.
Good morning. Today we've heard a lot about technology at various stages of the process that leads to the publication of finished publication. Today I'm going to talk to you about the authors because essentially they're sometimes fall by the wayside. We forget that they too have their own needs, and in doing so I would like to relate to what Elena said this morning about the role of AI in augmenting the capabilities of researchers in their day-to-day, and that's precisely what we're doing with summarization technology to enhance research. So the main issue that authors face nowadays is that they're completely drowning. There's so many publications. We've got an estimated 2.5 million new studies published every year. I'm sure this data is out of date already with the paper mills. But essentially, in order to get people's attention to those publications, summarization is one of the solutions. And we've, based on our own experience of doing summarized content by hand using science writers, we know that spreading summaries can enhance the impact of research studies. Depending on how you distribute these summaries, you can increase your impact between 3- and 5-fold. So what we've done is we've chosen to work with natural language processing as opposed to large language models for the very reason that there is no issue with hallucination. So we've used essentially extractive summarization to summarize research studies at scale. And in order to productize this further, for the very purpose of service, your end users, the authors, we've packaged this together and summarized research studies at scale in bulk before creating a meta feed. And that meta feed of summaries can be used to personalize the information that you deliver to your authors through simple filters relating to the institution, very specific keywords, and so on and so forth. So what we've done is essentially a news feed for scientists, which is made up of AI-generated summaries of research studies. It's a triaging system. It's a way of monitoring what's coming out of research. It's a productivity tool, foremost. And in order to make this embeddable widget, which can be hosted in a journal homepage, in an event page, in a microsite, anywhere you want, as a publisher, you offer this service to your authors, and essentially you allow them to monitor what's coming out of research on the one hand, and you keep bringing them back by pulling them in, by offering them the capability of summarizing their own research on the fly. So this is what we do, and I would very much welcome your questions. Thank you.
Global research shows that it takes the non-native English speakers on average 51% more time to write a paper, which equals out to about an extra 8 hours of editing per manuscript. Over the course of their career, that equals about 3 months of additional work, creating an unequal divide between those who speak English as a native language and those that don't. Enter Curie, an AI-powered tool built for writing and optimized for science. It saves the average researcher 12 hours per publication. Curie is specifically trained on academic literature, spanning 447 areas of study, more than 2,000 field-specific topics, and over 1 million edits. So what is Curie exactly? It's an on-demand editing and translation solution for scholarly publication. What we hear most from researchers, librarians, institutions, etc., is that quality is the #1 thing that they're looking for in an editing solution. We have the highest number of quality edits of any AI-based editing tool, with the highest correct percentage of changes. Similarly, we have the fewest number of incorrect suggestions that are submitted to a paper. For those that don't speak English as a second language, or as a first language, this is particularly important. We see that this increases chances for publication, and in a recent pilot, we found that those that used Curie had an increase of 14% for their chance of getting published in a high-impact journal. Thank you.
Hi, I'm Yuri from Appetence. We do a lot of stuff for the STM market, but today I'm going to talk about something probably a little bit boring, but extremely practical. Let's talk about persistent identifiers. We all know probably all publishers use of them somewhere. They use Ringgold, they use Grid, use Fundref, use ROR, but not consistently. So what you probably end up is with large Excel files filled with affiliation texts in various languages. Why is it a problem? It is not easy to work with textual affiliations. Let's say personal identifiers are really crucial if you are doing reporting, if you are doing a deal assignment, if you're doing eligibility flow. So you need like a single ID which you can use through the whole process. Our solution combines actually the ROR search, which sometimes works. We have measured 50% of successful, let's say, identifications, but we augmented with human teams which can process human intelligence task teams which can enhance the results of the raw search. And we also augment the raw search with NLP system which allows to extract correct institution names and then match it to the raw ID. So everything comes together in a multi-step process, and this process is available as a standalone service, but it is also available as an API. And if you want to know more about how it works, how it can help you to streamline PIDs through your workflow, please come by. I would be more than happy to answer your questions.
Hi, I'm Adam from Clear Skies. So what did we do last year? Well, you might have seen this recent piece in Nature News. This comes from an estimate that I did on working out the kind of scale of paper milling. This is quite rough, and it's meant to be kind of like a lower bound. It's possible that the rate is much higher than this, but it's not possible that it's much lower. If you break it down by subject area, it starts to get really interesting. Loads of really fun stuff to explore here. Scientifically, what we're looking at here is quite useless, but I thought it looked nice, so I thought I'd include it in this presentation. In doing this kind of investigation, we found quite a lot of cases of journals. This is a monthly output of a journal, where it looks like they're being targeted by paper mills. And we found a few of these. In fact, these were kind of predictions, right? Because all of these journals had mass retractions, and we knew about that before they happened. We've also been able to find some of the individuals who we think are running these operations. But now, you can actually see that in a live web app, so you can actually look at this yourself for your own publisher or your own journals and see the trends over time and see which journals are being targeted. I think the best thing from the last year has been working with a lot of you and a lot of other people in this community. There is a real community around this problem now. STM in particular have been great to work with. We've done a lot of work on detection. I think the thing to do now is to work out what is the best response to this problem. If you want to know about what we're doing in 2024, come and have a chat. Thank you.
These flash talks are so fast, I bet even the Flash would struggle to keep pace with it. Now let me spark your interest with two game-changing solutions from Molecular Connections that not only captivate authors, but also empower editorial teams to make decisions backed by AI and data. Introducing the Author Keyword Recommendation System and the Journal Recommendation System. Let me walk you through the first one, AI-based keyword recommendation system for the authors with the objective of improving author engagement and content discoverability for publishers by generating high-quality metadata upstream in the publishing process. I'm going to talk less. Let's watch this quick video.
When an author submits a manuscript, we assign the best taxonomy terms and keywords for the manuscript. As a critical step in the publishing process, we ask the author to accept the auto-generated keywords or select more appropriate keywords. The author is notified with an email that has the link to Manuscript Keyword Manager. On the right side, we have the Keyword Manager where one can review the suggested keywords. The Add Keywords field allows the authors to either enter their own keywords or select from a list of relevant keywords belonging to the subject areas or domains from our portfolio. After finalizing, the author can choose to submit the keywords by clicking on the Submit button. After an overall review, author can proceed with the final submission, with the entire process taking less than 5 minutes.
As you can therefore see, the platform provides a feedback loop which allows for a timely review of first-hand requests from authors and editors to include emerging topics, of course supports improved discoverability, enabling content integration and so forth. Moving on to the next solution, AI-based journal recommendation system for editors and authors to improve journal selection, author engagement, and build an automatic manuscript transfer desk.
Journal Recommendation System recommends the most relevant journal, suited for publishing a manuscript by an author. On the JRS application, the author has to enter the title and abstract of their manuscript. The author then clicks on the Suggest Journals button and a list of the top 3 most relevant journals comes up. Comprehensive journal details like relevancy percentage, access type, frequency and publication type, article processing charges, keywords, and scope are shown along with the results. The recommendations can be further refined using relevant keywords and the Open Access Journal toggle button. After finalizing the journal, the author can proceed and click on the Submit button, which will take the author to the respective journal manuscript submission portal. JRS, with its plug-and-play model, allows you to customize the application to any specific requirements.
The JRS helps with real-time journal alignment checks, tracking trends, improving transfer desk suggestions and workflow efficiencies, and of course allows for improved author engagement. Both the solutions that I just presented are plug-and-play, modular, and integration ready with all major submission systems like ScholarOne, EJPress, Aries, and can be implemented in less than 3 weeks without any disruption to your existing workflows. Thank you so much. We don't have a table here, but I'm around here and tomorrow if you have any questions for us. Thank you so much.
Hello. So I'm Tim Vines from DataSeer. We're a service provider around open science. So if you're not yet thinking about open science, you will be. It's because it's too easy to publish fake science. Readers can't check the articles because the data encoder almost never available alongside the article. So it's hard to know whether the articles are really saying what they're saying. And systematic reviews, this is a very basic problem. Systematic reviews, which we use to decide which medicines to allow into the public sphere, are based on summary statistics and not on raw data. This is a massive problem and we need to fix it. So we need to enable open science, and this is when data encode and other outputs are shared alongside scientific articles. And all stakeholders want open science to happen, but we have not made much progress. This is because A, we can't efficiently monitor it, and B, we can't promote it at the article level. So DataSeer has 2 solutions that help here. Open science metrics, if you're aware of PLOS's open science indicators, we are the provider for those, for PLOS. We also do, these are 2 graphs of examples from 2 different institutions that we've done survey work for. You can see the one on the left has a lot more of their authors sharing data compared to the one on the right. The gold color is the data being shared online. We also can look at things like where the authors are sharing their data. You can see here that a lot of authors are sharing on GitHub in both institutions, and we can see that there's a lot of preprinting on bioRxiv and on PeerJ preprints and ResearchSquare. So this is the kind of information that organizations throughout science publishing are going to need to take action on open science in future. We also enable authors to comply with policies by producing detailed reports listing the data sets that they have generated and other outputs that they've generated for their article, and telling them how they need to share them to comply with an open science mandate. Thank you very much.
Hello everyone, I'm Juan, I'm co-founder and CEO at Rifle. So what we do at Rifle is that we offer language and metadata services for both publishers and researchers. We own our AI, so the models that we build it ourselves, and they are tailored to academic writing. So no customer data is stored or used for training our models. So I wanted to hit on 2 APIs today. The first one is a manuscript categorization API. This API enables publishers to know the language editings of manuscripts. So for example, this is useful to negotiate pricing with vendors. And this was tested with ACS, and they saw a 95% alignment between what Rifle was producing and the manual categorization. The second is a language edit assist. And this one, what it does is to apply a subset or all of the Rifle edits, so that before copy editing, you can lower the vendor costs or speed up the in-house editing. So Rifle has been working with ACS for a while now. We won an RFP a few years ago against all our competitors, and they've been recently vetting the language edit assist API. So they did this interesting study where they split 700 papers into groups, and half of them would go through the Language Assist API. They saw that those manuscripts that went through this API improved the amount of the percentage of well-written manuscripts improved from 58% to 81%. And they also saw that all the manuscripts that have gone through this API needed a significant amount of lower editing needs. They also analyzed 35,000 edits made by Rifle manually, and they saw that over 99% of them had been applied without any errors. And of those where an error was introduced, only 0.3% were unexpected. So a Rifle is really everything about gaining efficiencies and lowering costs, and we tend to work closely with publishers to streamline their workflows using this technology. So if you have any questions, please come back later. Thanks.
I love using my submission system. I enjoy it, and I'm delighted by it. Said nobody. And this is what we're committed to do at Maurissier, which is build the future of publishing workflows. You know, a lot of times we take integrity now as being an afterthought of the architecture and the infrastructure we build in our submission systems. At Maurissier, we're building it from a basis of integrity embedded through every step of the process. We're also building it on modern technology, so it's intelligent, using all of the great technologies that you're hearing here, connected through third-party integrations within our infrastructure. It's simple, so we pride ourselves in our UX, in our user experience, in our ability and intuitive way of interacting with the system. And it's connected, so all of the data sources that you hear about, many times it's very difficult to get that data in. This is something that we're building from the start. Authoring manuscripts, many times this is the biggest challenge. You have a lot of uploads of PDFs and then sending that back to reviewers and editors. Imagine a world where in your submission system you actually have the authoring capability. We have that technology accessible to us in our normal lives through Google Docs and Word, where you have reviewers and track changes and commentary all tracked within one document and being able to submit it into multiple formats. That's what a submission system should include, and that makes the rest of the process easy. Imagine the hundreds of millions of dollars that go into just getting your manuscript ready for publication. If you have it set to be in a certain format from the beginning where you have the actual data in your control, you can create it and share it and publish it in any format necessary. Managing submissions at scale is always the toughest thing, and being able to visualize that, categorize that, and know which submissions are sitting in what stages is something that is an expected experience and yet doesn't exist in many places, in many systems. And then being able to then assess those submissions at scale with the level of integrity, with the level of knowledge, with the level of data and markers that allow you to make decisions is something that is built into the future systems. Inviting reviewers and now having machine learning and AI actually help support you with all of the data that you have about those reviewers, about the manuscript, about the topic. Because you have all of that data at your fingertips, you now get suggestions and recommendations on who to use, which then helps us to alleviate a lot of the biases that we have where we just focus on a specific reviewer pool. Now you have at your disposal the ability to diversify that. And now you can have a look at your entire portfolio at scale. What are the issues that you're seeing? What are the submissions and the scale at which you're seeing some of the issues that we've been talking about here with many of the technologies? And how do you make decisions based on that? That's the future. It's scalable, it's efficient, and hopefully it's satisfying, and that's the goal that we hold ourselves to. Thank you so much. Looking forward to talking to you soon.
I'm a medical doctor with 20 years of research experience, and I want to tell you I'm not a big fan of graphical abstracts. Okay, I admit, you take the research on the left and you turn it into the visual abstract on the right, and it gets a lot more visibility. And okay, I give you that. Visual abstracts are an industry trend. And there are more than 1,000 journals supporting visual abstracts these days. So, what is wrong with visual abstracts? Mainly two things. They're too expensive. $500, that's the average price. And production is way too slow. You wait for 7 days on average for your first draft. So what is our solution? Our company is called Visual Abstract, and we developed a software that can produce visual abstracts in 3, 2, 1 seconds. So on the left, authors order with 2 clicks. Our system produces the first draft, and then on the right, the authors review the output to make sure everything is accurate. Now, when you're that fast, what else can you build? Well, here's just an example, something we've been piloting with 16 journals over the last 6 months. First part of the offer. For accepted manuscripts that are not yet published, we offer on-demand visual abstracts, author-reviewed, publication-ready in under 72 hours. Second part of the offer. Once the manuscript is published, we create AI-generated social media content. We tag the authors, we tag the journal, we create additional exposure. So how do the authors like our service? They love it. Does our service slow down publication times? No. We deliver the first draft in under 12 hours. And do we charge $1,000 for that service? Nope, just $290. So to sum up, journals now get visual abstracts for half the price, 14 times faster with additional content, and that's roughly estimated a productivity increase of 2,000%. If I got your attention, let's talk further. We're on the table right there with the gentleman behind you. Now it's up to you. Thank you.
All right, that was the last of the lightning talks. I propose we give them all one big round of applause.